Akwaba to the math classroom. If you are new to my channel, kindly don't forget to subscribe, like and share the video among your networks. And to my already subscribers, I say thank you. Our lesson today focuses on linearity of differential equations. If you've not watched the lecture videos on the definition and examples of differential equations, I urge you to do so. Over the last weeks, we've been looking at classification of differential equations. We made mention of the type, order, and degree, which the link is provided in the description of this video. And today we are looking at linearity. At what conditions can we say a differential equation is linear or non-linear? We are saying the conditions are as follows. 1. The dependent variable and all its derivatives occur only in the first degree. If I have a function, let's say this is my function, y, to be equal to f of what? X. This is what? A function. The dependent variable we have here is what? Y. So that if I have a derivative, and my derivative is what? Dy dx. So I have a derivative, dy dy x. What we are saying is that whether the dependent variable, which is y, or the derivative, which is dy dx, should only occur in the first degree. So I can't have a function where I have, if I take this function and I write 3y squared to be equal to what? 2x. What we are saying is, with this dependent variable, which is y, the degree here should always be what? In what? The first degree. The first degree. So that even with my derivative, if I have dy dx, what is the degree of this? The degree of this is what? 1. Same with if I have dy, the squared y over dx squared, and I ask you to find the degree of this derivative, you realize that the degree here is also what? Equal to 1. It is what? In the first degree. So let's say I have this. If you have dy over dx, this is what? A differential equation equal to what? 3x squared. What is our dependent variable? Our dependent variable here is what? Y. So you ask yourself, what is the degree of y here? You realize that it is what? To the power 1. If I take the derivative in my differential equation, you realize also that the degree here is also what? 1. Then it is what? Linear. But is that the only condition to say a differential equation is linear? No. The second condition says that no product of the dependent variable, say y, and or any of its derivative words present. So if I have the dependent variable, say y, and the derivative, the y, the what? X. What does it say? It says that there is no way I should have the dependent variable y multiplying what? The derivative. So that if I have anything like this, then we are saying this is what? Not what? Correct. So this can't what? Happen. So that if I have this differential equation, so I have dy over the x to be equal to what? 3x what? Squared. If I have anything like this, you ask yourself, is it linear or is what? Non-linear? From here, you realize that you have the dependent variable multiplying its derivative. So we can't say it is what? Linear. So it becomes what? Non-linear here. So that when you are given a differential equation, like we have here, you check. The first thing to check is the dependent variable and its derivative in the first degree? Yes. Then the next thing to check is, do I have the dependent variable multiplying the derivative? No. So this differential equation passes. Then the third property or the third condition says that you should not have no transcendental function. So I have no transcendental function. What are our transcendental function? These are you should not have a logarithm, either trig function. So you have trig, let's say trig functions, exponential functions, and the logarithm functions. So our log functions are what we are calling the transcendental functions. So we are saying do not have any transcendental function of the dependent variable and or its derivatives. So that if I have a function y to be equal to f of x, under no circumstance should I have this function, let's say cos of the dependent variable or sine, or you could have an exponential function e to the power y, which is a dependent variable, or you could have ln y or log y. Under no circumstance should you have anything like this. So under no circumstance do we want to have anything of this sort. So if it happens so, then this is a no-no. That is it makes it non-linear. So that anytime a differential equation is given to me, you check out for this. Let's look at this example. Let's take this differential equation. I have 3x squared y prime prime plus 2 ln x y prime plus e x y to be equal to 3x cos x. Let's find out if this differential equation is linear. So you want to check if it is linear. Okay, so what does the first condition says? It says all the dependent variable and its derivatives should be in the first degree. So let's check the derivative. This is a derivative. This is the dependent function. Is it in the first degree? Yes, correct. Do we have the dependent variable multiplying a derivative? No. So you check for the third property as well. So you realize that the third property, do you have any transcendental function? Yes, I have cos. But is it with the dependent variable? No. So you realize that then this differential equation passes to be a linear differential equation. So you can describe this differential equation. If you describe the differential equation, what do you have? You realize that you have what is the order of this differential equation? It's a second order differential equation. So I have a second order linear differential ordinary differential equation. Thank you, and don't forget to subscribe.